All right, awesome. Thank you for being here. Let me stop my share and get started. Welcome to Ask an Expert, Understanding Ocean Noise, a science briefing for the California Legislature that is also open to the public. This is brought to you by the California Ocean Science Trust, and my name is Peavey. I'm a senior science officer with the California Ocean Science Trust, and I will be your MC today. I'd also like to start by thanking our partners on this event, which is sponsored by the Office of President Pro Tempore Emeritus Tony G. Atkins, who represents the 39th Senate District. We are so fortunate to have your partnership and your leadership. The 39th District includes the Scripps Institute of Oceanography at UC California, at UC, the University of California, San Diego, who is also our partner on this event, so thank you to Scripps. For those of you who don't know us, OST is a 501c3 nonprofit created by the California Legislature more than 20 years ago to bridge the gap between cutting-edge scientific research and sound ocean governance in support of accelerated progress towards healthy oceans and coasts. This briefing is brought to you by OST's Legislative Science Services Program, which brings science advice to lawmakers. I think we have an excellent speaker lineup for you today. They will be offering high-level science perspectives on ocean noise with a focus on implications for California's ocean and coastal environment, with some actual fun sounds and noises for you to listen to. And their research explores the natural ocean soundscape, human sources of ocean noise, and their potential environmental impacts, and the value of ongoing acoustic monitoring for understanding ecosystem change. I want to offer a special thank you to Roxanne Garibay, our CSU Coast intern this summer, who's been a rock star and has led the scoping, organization, and execution of this briefing. So big credit to Roxanne and to the CSU's Coast intern program. This event will be recorded. The run of show today will be lightning talks by our 5 speakers, followed by open discussion. We call this an Ask an Expert briefing because we want our audience to be engaged with the material, and we welcome questions. Please use the Q&A function so we can track them. We'll even keep the webinar open a few minutes after the planned 12:30 close to ensure we have enough time to address any lingering questions. So let's get to it. I'm going to invite Dr. John Hildebrand to turn on his video and join me. Dr. Hildebrand is Distinguished Professor of Oceanography at the Scripps Institution of Oceanography and our moderator today. The rest of our panel, who you will meet in a moment, includes Dr. Lindsey Peavey Reeves, the West Coast Region Sanctuary Soundscape Monitoring Program Coordinator at the NOAA Office of National Marine Sanctuaries. We also have Dr. Simone Baumann-Pickering, Professor of Oceanography, also at Scripps, Dr. Vanessa ZoBell, postdoctoral researcher at the Machine Listening Lab, also at Scripps, and Dr. John Ryan, Senior Research Specialist at the Monterey Bay Aquarium Research Institute. So I'm going to go ahead and hand it over to you, John, and I will see you on the other side in discussion.
Thank you, Kia and Roxanne, for inviting me and for putting together the panel. And I think this really is a great topic because there's been so much progress in this area over the last, say, decade or so. So I'm going to see if I can share my screen. And now, hopefully, let me know. I'm showing a picture of sounds offshore California and various things that we're going to listen to. So let me know if that's not what you're seeing. But I want to start out just saying something about how when I started in this business, several decades ago, the main agency that was interested in underwater sound was the Navy, because the Navy uses acoustics for a lot of its operations in tracking submarines and ships. But over the last few decades, the value of acoustic monitoring for studying marine ecology has really become apparent. And this is drawn into the study of underwater sound agencies like NOAA that are responsible for, protected species, fisheries and marine mammals and that kind of thing. So at this point, acoustic monitoring is really one of the best ways that we have to get a long-term view of the marine ecology, because all of the sounds that are made by these various organisms appear. A lot of the anthropogenic sounds like ships and sonars appear. And, putting all this together, it's really a great sort of time series of what's happened in the ocean. And this is particularly true if you talk about the coast of California. And it's partly because the various organizations like Scripps, Monterey, the Sanctuaries, that we've all become engaged in the study. And this is what you're going to see in the presentations today. So just to show you the characters here, this is a sort of snapshot of some of the animals and objects that I'm going to play the sounds for. So I get the fun part of the presentation where I get to play you a bunch of sounds. And so we're going to start with the sounds of fish. And you might think that fish wouldn't make sound because they'd be worried about getting eaten, but they also have to find each other. And so a lot of these sounds are related to breeding of fish. That was the sound of a midshipman, which is basically a fish that lives on the bottom. Here is a rockfish, the boccaccio. People used to call that a motorboat sound. And then invertebrates, snapping shrimp, also make some of the highest amplitude sounds that you find out in the ocean. The snapping shrimp have a little claw, and every time the claw snaps, you get one of these little clicks. Now, as we kind of work our way up, we have the pinnipeds. So this is a sea lion. Those of you who go to the beach are familiar with that because sea lions are both in the water and out of the water. Now, this is a seal, and it's a bearded seal, which lives a little bit further north here, but it gives you a sense of how dramatic some of these sounds can be. Here's a walrus, again, something that is a little bit further north, but now when we go to the toothed whales, there are varieties of kinds of sounds that they make. The first is just clicking. And then there's a buzz. And then they're whistling. And then the mysticetes, these are the baleen whales, the large whales. There are a huge variety of sounds they make. Some will be familiar to you and some not. That's the first part of a song of a blue whale. And it's actually, on good speakers, it's really powerful. It's like standing in front of the speakers at a rock concert or whatever. This is a minke whale. And last but not least, the whale that has its own best-selling album. And that's a humpback whale. So you can see that the variety of sounds, these all appear in these long-term monitoring records, and they allow us to get a sense of kind of who's out there. And we're working now more to being able to actually, oops, oh, I knew that was going to happen. Let's just see. I need to go to the next slide. I'm sorry. I had that. This is the the trickiness of PowerPoint. You don't want to hear them again. So anyway, we're getting more quantitative about being able to count the sounds and by that, count the animals. So on the other hand, we know that there's a lot of anthropogenic noise off of California. This is a snapshot from the automatic information system, which tracks ships, and you can see the density of shipping along the California coast. And the relevance of that is that especially large ships like container ships have powerful propellers, and that creates a really high amplitude sound. And when we describe this, we have to use the decibel. This is like tens of Alexander Graham bells. It's a big B because it's a unit identified by Alexander Graham Bell, but it's in pressure, and the decibel is a logarithmic measure. And so the black lines at the bottom are our best estimate for what the ocean would be like if there were no ships. And you can see that the average sound levels at a place like, along the continental shelf off California near San Nicolas Island or in the Santa Barbara Channel, they're 20 to 30 dBs above what the ocean would be like in the absence of ships. So that means that it could be 1,000 times more powerful, the anthropogenic sound made by ships as opposed to the sound that would naturally be present. The other thing that's important about offshore California is that it's an amazingly rich ecosystem. And this comes about partly because of the California current system. There's a current that comes in from the North Pacific and goes down along the coast of California. This creates an upwelling, which gives chlorophyll, which creates the nutrients so you can have, chlorophyll, and then, in phytoplankton, and then zooplankton, the animals eat the phytoplankton, and then the fish eat the zooplankton, and on. But that red blotch along the coast of California explains, just how rich an ecosystem this is. So having said that, now I am going to defer to Lindsey Peavey, who will tell you about work by the Sanctuary.
Lindsey, you're on mute still.
Yeah, I saw that. Thank you. Hello, everyone. Thanks for having me. I echo John's thanks in putting this together and having us here. Let me share my screen here. It's always so inspiring to hear those isolated sounds, and we should have a quiz at the end. That would be fun. Hopefully everyone can hear me okay and see my screen. If not, holler and we can rectify that. But all looks good. Okay, great. So I'm going to take a little bit step back and talk about why are we monitoring sound in the ocean at all? And there's some really good reasons for that. Sound travels 4.3 times faster in water than in air. So when we're recording sound underwater, we can actually hear the sound sources oftentimes very, very far away. And of course, animals experience that same phenomenon. And another reason is that all light is absorbed within 200 meters of the ocean surface. So that top part of the water column is really the only place where animals have visual cues. And so unlike humans on land where we do rely on our visual cues, marine animals rely on sound for survival, for foraging, social interactions, navigation, reproduction. So that's really the key element for their thriving, their ability to thrive, is that they can produce sound and receive sound. So John got to play all of those really fun isolated sounds so that you could hear them really clearly. But in reality, underwater, it's a cacophony of sounds happening at the same time. And so this is just sort of one high level depiction of various sound sources overlapping in time and space. So you can see there's abiotic sounds, anthropogenic sounds, biological sounds. John mentioned this as well. We call this an ocean soundscape. Here's a really tangible example for California. So this is my backyard. I'm in Santa Barbara, California, Behind me is the Channel Islands National Marine Sanctuary. So this is a federal marine protected area. Embedded within that are some of those California state marine reserves. So, you know, John mentioned how special our coastline is. And so these are some of the sound sources that we're interested in this particular marine protected area in understanding. So we want to generate those long time series, those baseline understanding of the conditions that exist in these areas offshore. So how do we monitor sound in the ocean? Unfortunately, I don't have time to go through all of these different approaches, but what I really want you to gather from this is that we have a lot of tools in the toolbox. John talked a little bit about the history of marine acoustics, and so we've kind of come to this place where we have a lot of different tools, and they span from really basic technology that's very accessible and very easy to use to innovative, sophisticated technology that might be costly and you know, have a higher barrier in terms of accessibility and ease of use. We can also track animals through the environments in this way as well. And so there's also a gradient of temporal and spatial scales that we can get at with these tools. And so often we're using a lot of these tools in combination and also integrated with other types of information like environmental variables. So what can animals hear underwater? I think this is a nice figure that kind of depicts the overlap in sort of frequency space. So the x-axis here, you can see low frequency on the left, all the way up to high frequency on the right. That yellow highlighted part of that axis is actually human hearing. So you can see in the marine environment, lots of sound happening below and above human hearing. Some of the species that John played for you can see their hearing ranges. They're highlighted in green. What's overlaid on that is the other elements of the soundscape, including the human-induced noise. And so you can see lots and lots of overlap, which could cause a potential negative impact. And that's what we're here today to talk about. So I want to give you an idea of where we're actually monitoring as well. So focusing on that map on the right, if you look at the larger map, the inset, the smaller map, the inset, that is the entire West Coast. You can see we have a lot of effort there off of the California coast. So the larger map is a zoom in of California. This is not comprehensive of all of those technologies that I showed you previously. This is just bottom moored listening stations. So we put a recorder in one place, we know the listening footprint, and we have this really long time series. We can generate those baseline understandings of the characteristics of the soundscape in these areas. So know that that's not comprehensive. There's more effort happening in between these spaces. But what I do want you to take away from the California map is that we do have some pretty big passive acoustic monitoring effort gaps up in Northern California. So it takes a lot of coordination and a lot of effort and a lot of expertise to pull this off, to create a network like this and to have it be sustainable through time. We're doing this collaboratively. On the next slide, I'm going to show you a ton of logos of some of the partners that are working on this. But we're all doing this to collectively support management. So lots of cool questions we can answer about biology, but really we want to improve the health of our ecosystems, or in some cases maintain healthy ecosystems off of our coast. So some of the things that we can do with these long time series are understand species presence, including humans in these marine environments, support restoration efforts, understand how we're complying with regulations, understanding climate change, and tracking status and trends of resources. We'll hear some examples of that on the panel. Measuring change, of course. If we don't have the baseline, we can't measure change. And of course, we want to quantify the human impacts, and that's where noise comes in. So I think hopefully by now it's clear that just a loud marine soundscape does not necessarily mean there's noise involved that would create a negative impact. A healthy reef, for example, can be quite loud. So it's really when there's a human introduced noise that could interfere with the natural interactions in the marine soundscape is when we have a problem. So I promise to show you, hopefully this is close to comprehensive. I'm sure I'm forgetting some key people here, but I just want you to know that there's a lot of organizations that are not only implementing this monitoring off our coast, but also cost sharing And that's a really important aspect to keep in mind, is that sometimes it's nice, it's easier to follow the new shiny thing in terms of funding, but we really need to maintain these long time series that John mentioned and that you're going to hear about on the panel. So quickly, I just want to stress the importance of these baselines and show you kind of what we can do with that baseline understanding. So this is an example. The figure on the left is that cacophony of sound. So the whole soundscape we're seeing here going through day by day. So you can see this long time series. We don't have a lot of data gaps. We can listen 24/7 with our hydrophones. And so this is the Monterey Bay National Marine Sanctuary. And with this information, we can start to categorize what the soundscape conditions are normally. And so what you see on the right is we can start to understand what's dominating the sound in the environment. You know, what portion is dominated by biologics, what portion is dominated by human-induced noise, what portion is dominated by the natural environment. And from this baseline, we can see how does that change over time and what are the drivers of that change. And we can also evaluate management actions, which you're going to hear about today on the panel as well. Going to finish up by just saying all of this data is open access. That network that I showed you, all those partners are dedicated to standardizing the data collection and the data processing and the data product so that we're comparing apples to apples across time and space. The data is available here in a federal repository. And lastly, again, we don't have time to go into the examples of how we're sharing this broadly, but it's very important that we interpret the results and that we share our understanding to a wide variety of audiences. So this is just one example, a web portal from the Sync Sound project. You can go here and explore all of these tiles, especially the what did we learn? And you can see, you know, what are the bits and pieces of the take-home messages that we're really trying to get to a variety of audiences. So I'm going to pass it over to Simone now, and she is going to talk a little bit more about the impacts.
All right. Thank you for the great handover here to impacts of anthropogenic noise on marine life. I'm Simone Baumann-Pickering, as mentioned previously, professor at Scripps Institution of Oceanography. And when we're about noise, and you probably can hear in the background the cacophony of noise going on, it's really annoying when you have to listen to this cacophony while you're trying to focus on the speaker. And so that's why I'm going to turn this off, because you don't want to have that kind of masking, but that is essentially what the animals are having to overcome in their communication efforts in their daily lives. Now, what I just displayed was an impact that is kind of at the back end. It's an annoyance impact, and that may then cause me to change my behavior. Now, sound impacts can be much more drastic. If a source is very loud and an individual, be it animal or person, is very close to that source, that can lead actually to a direct mortality. Now, those cases are very, very rare. It can lead to injury if one is a little bit further removed or the source isn't quite as loud. That could be something like a ruptured eardrum. As this impact is being yet a little bit lesser, and you probably all have experienced that in your lifetime, if you were at a concert or in a loud bar environment, you may walk out of that and have some kind of dullness in your hearing, and that goes away after a little while. And so that would be then a temporary impairment of your hearing due to that noise. And though the one portion, and I put a bit of a question mark in, where we're still trying to figure things out in a bigger way, is what kind of long-term physiological behavioral changes does both impulsive but also chronic noise exposure lead to? And there's a bit of a complex overview here where you basically have your general ecological drivers of behavior, changes in the ocean, changes in food sources, and then comes that anthropogenic stressor on top of that. And that then can mean that you have physiological changes. So, for example, stress level might go up, or like I said, actual injury might occur. Or you may decide to change your behavior to say, okay, I'm going to move away from this stressor, from this noise source, and go find foraging grounds elsewhere. Now, there are costs involved in that decision. You will have an interruption in foraging, and you need to spend energy to actually get to that new place that you're trying to reach. And so with that, then overall health of that individual that has to make that behavioral change could come into place, where not only are stress level high, you're losing foraging opportunities, so you're potentially malnutritioned. Overall immune system is going to be impacted if that happens over and over again. And ultimately, then it gets down to survival, fecundity rate, growth rate, and that can lead to some population level consequences of disturbance, so that individuals may not reproduce at the rate that they would be expected due to that anthropogenic pressure. And we see declining population rates. Now, we've been working a lot offshore California with deep divers, specifically these goose-beaked whales. It's about a quarter of all cetacean species have evolved to forage in really deep waters below 1,000 meters or about 3,000 feet water depth. And they access resources like deep sea squid and some deep sea fish. And there has been quite a bit of controversy in the use of naval sonar because there have been mortalities related to use of naval sonar, not here locally, but in other parts of the world. Here locally, we're more concerned of the conflict between use of naval sonar and these probably resident populations of those deep divers and those long-term consequences of chronic exposure to naval sound. We have a couple sites that are associated with the local offshore training range off of San Clemente Island, where we have records starting in 2009 to in this case 2019, but it's actually until present. So there's natural variability in presence that is driven, like I said earlier, by natural things like, is it a good year for prey? Is it an El Nino or La Nina condition? There are seasonality components to presence, and there is a preference for foraging certain times of day. So we need to account for all of this before we then can understand what is the influence of the pressure. And so this is now showing that we see the animals coming back after sonar has stopped after a day or so, but then longer lags actually don't occur here locally. And so we see that if we were to truly stop for a good long while, we would have a lot more presence at these Navy ranges of animals. And then certainly we see a reduction in presence as the sounds are increasingly loud. So those are kind of our main take-home messages here. We have a study off of Guadalupe Island in Baja California, where we were able to identify an avoidance behavior when ships were present that had so-called ultrasonic anti-fouling. It's a transducer that is mounted on boat hulls to avoid growth of plankton on the ship hulls. And you can see down here, when the sound is on, this is a time period of a couple of years, we see a clear avoidance of these animals. Down here, you can see in blue, all of these time periods are time periods when the animals are actively foraging. And visual surveys document that the animals are displaced from their primary preferred habitat. So that means in this case, more and more ships are leaning towards this technology. They go to some of protected marine spaces, very popular also on cruise ships. And there's really no regulation of this technology as current. Lastly, big topic in California is the development of floating offshore wind energy. And the question is, what kind of impacts would we expect on marine mammals in that realm? And while there are a number of potential conflicts that marine life would be encountering, one topic is certainly noise. And that noise relates to both pre-installation activities, the actual installation of these wind turbines, but then also operational noise and decommissioning at some point, hopefully way down the line. All right, in summary, the impact of ocean noise range from direct mortality to physiological and behavioral changes that may lead to population level consequences of disturbance, particularly as it relates to these chronic disturbances. And we are starting to have guidelines and management actions starting to be in place. However, there's still a good amount of work to be done in that realm. And I think the following speakers are going to be touching on that. So with that, I am going to hand over to Vanessa.
Awesome. Thanks, Simone. I will just share my screen. Okay, can everyone see that? Okay, awesome. So hi, my name is Vanessa ZoBell. I'm a postdoctoral researcher at Scripps Institution of Oceanography. And as Simone mentioned, there's many different anthropogenic impacts that are going on off of the coast of California and all around the world that can negatively impact animals in terms of communication, masking, physiological impacts, behavioral changes, and damage to hearing structures. But for many of, or at least for shipping, we really need to be able to have shipping and be able to get our goods and trade with other countries in a way that is sustainable. So today, around 80 to 90% of the world's goods, including our computers that we're all tuning in with, were once on a container ship. So how can we work with partners to figure out ways that we can get these goods that isn't causing damage to these animals and to these environments? And I know a couple sounds were played so far, but this is what a container ship off of the port of LA sounds like. Unfortunately, not as beautiful as the whales that John was playing earlier, but still important to study. So zooming into Southern California, right off of the Port of Los Angeles and Long Beach, Port of LA and Long Beach are the first and the second busiest shipping ports in the Western Hemisphere. And interestingly, they intersect the shipping lanes that transports goods to and from these ports intersect with critical habitats, including the Channel Islands National Marine Sanctuary, and the blue whale biologically important area and the humpback whale BIA. Both of these animals are considered endangered under the Endangered Species Act and protected under the Marine Mammal Protection Act. So a really interesting area to study where we have this hugely, richly biodiverse critical habitats right up next to the busiest shipping ports in the world. So we made a model of the noise around this area in space and time. And you can see here, the black lines are the vessel tracks of the vessels transiting in the area, and the colors represent the noise from these ships. So red is higher noise and blue is quieter noises. And you can see that the ship noise extends far beyond the track lines. It spreads and propagates over wide areas. So in order to figure out how to reduce these noise footprints, we need to take into account their operations and design. And we have 2 recording devices in this area where these stars are, and we've been recording for over a decade. And it's really interesting because the changes that we've seen in this soundscape reflect some socioeconomic events that have changed shipping and have changed the soundscape over time. So in 2008, ship noise was the highest it's ever been, but with the economic recession, there was less shipping in this area that drastically reduced the ship count and the noise. So red is the noise, and then the blue lines are the ship counts. And then additional events that went on, like labor negotiations by the dock workers, anchorage congestion in the end of 2021, if you remember, those hundreds of ships that were docked off of the or that were anchored off the coast of Southern California trying to get into the port of LA. We saw a big increase in noise then, and then queuing, which was implemented right in 2022, which kind of allowed the noise to reduce for a little bit. But we can see that with the reduction in ships, and there was a reduction in ship noise, and we want to figure out how we can reduce noise pollution in this area over the long term. So there's a couple different strategies that are being investigated right now. One is an operational strategy where we partner with a program called the Protecting Blue Whales and Blue Skies program, which initially was just off of Southern California, but has now extended to the whole California coast. And they voluntarily, or they incentivize the shipping company to voluntarily reduce their speed, which we found reduces underwater radiated noise from these vessels. And this program has extended to Northern California, and our next speaker will be talking about some of the other co-benefits that go along with reducing underwater radiated noise in this region. So in addition to operational changes that these ships can undergo, there's also different designs that are being looked into by the shipping industry themselves and by the International Maritime Organization. So operational methods are really helpful in areas where you have a critical habitat that you want to strategically reduce noise around, but shipping specifically is an international effort. So having methods to reduce noise extending beyond these regions is also helpful. So we partnered with Maersk, one of the biggest shipping companies in the world, a couple years ago to investigate the noise reduction brought about by one of their redesign efforts. And we found that post redesigning or retrofitting the vessel, there was a noise reduction in the low frequencies. And there's so many other vessel designs that are coming out. There's hydrogen hybrid systems, electric engines. So I think that this is a really interesting place of research right now. So another effort to reduce noise is marine spatial planning, which is an option that includes, instead of reducing noise at the source of the ship, you're actually just moving the noise to an area of less concern. So a current event going on right now, there's a port access route study, which is proposing new fairways or changes to shipping lanes off the coast of California. There is a proposed fairway being proposed by the U.S. Coast Guard that wraps around the southern side of the Channel Islands National Marine Sanctuary. So we wanted to see what the soundscape would be like with this implemented change before it actually goes into effect. And we found that the soundscape was actually, the underwater radiated noise was increased on the southern side of the islands in an area that used to be relatively pristine. So I think that marine spatial planning is needed in order to figure out ways to help some of these areas remain pristine and reduce noise pollution further in these critical habitats. So just some takeaways here. Human activities, including shipping, can radiate noise pollution into the ocean, but there are many different methods being explored to reduce noise in these areas. And I think there are many other noise reduction strategies that we have left to explore, like dynamic ocean management and investigating noise pollution in additional regions like Northern California, which isn't monitored as much as Southern California. So with that, I will let John Ryan from MBARI talk about additional strategies in a more Northern California, Monterey Bay area as well.
Thank you, Vanessa. And thank you, Ocean Science Trust, for the opportunity to contribute some perspective from Central California. So the region we're going to focus on now is a little bit north of where we've been looking. It's Central California, Monterey Bay National Marine Sanctuary, highlighted in blue here. And MARS is Monterey Accelerated Research System. It's a cabled observatory that is connected to the shore at Moss Landing with 32 miles of cable, so a live connection to the deep sea. And this cable observatory is supported by the National Science Foundation. The example of shipping noise that you heard Vanessa play looks like this. This is the sound. All of this red here during a period of more than 2 hours are high levels of noise caused by the transit of a very large ship, 3 football fields long, including the end zones. And this triangle on the map corresponds to this time as it moves past. This square corresponds to here. And all that I want to emphasize really here is masking. After the ship has pretty much passed out of our hearing range, you see all of this signal down here. This is a fin whale singing, putting out pulses and with intermittent breaks at the surface for breathing. But while the ship is passing by, the sound of that whale is entirely masked to our recorder. And also, if we look at the magnitude, 3 decibels is a doubling of noise intensity. When the ship is gone, we're down near 72. When the ship is producing its peak noise, it's about 92, so 20 decibels, very, very intense, even though the ship only gets to within about 12 miles of our recorder. The sound travels so well. Now, if we look at a time series, this is approximately 7 years of observations from that location. These are identified by quarters of a year from the 3rd quarter of 2017 up to nearly the present. And there's a lot of information here, but it basically shows you the ship noise metric well, as it depends on the hour of the day and the month of the full time series. And we see a lot of information here. All I want to focus on is something that Vanessa highlighted and others here have identified. Wherever you see a lot of blue, noise levels are unusually low or relatively quiet. And this whole period right in here during early 2020 was unusually quiet throughout the day because COVID impacted economic activity, port activity, and the movement of ships past our recorder. There were less ships coming by. Then for about a year, we had all of this red means that it was anomalously loud. And as you heard, the port logistics were quite chaotic in recovering from COVID impacts. And so ships couldn't easily get in and out of San Francisco ports either. So they were loitering between Monterey Bay and San Francisco Bay. And so we heard a lot more noise from them during that period. The second period in this 7-year time series I'd like to highlight is this very persistent quiet period. This corresponds with when Monterey Bay National Marine Sanctuary joined the voluntary ship speed reduction program that is run by Protecting Blue Whales, Blue Skies program. And we have never heard such persistent quiet conditions since the implementation of that. And that's really the key. Slowing down ships has so many benefits, not only reduced pollution by noise, but reduced pollution by carbon and reduced risk of ship strikes. And that's what I want to turn to, are these parallel benefits of such measures that are intended to improve the marine environment and conservation. So for that, I'm going to turn to a type of hydrophone on the cabled observatory that not only measures the pressure signal that your eardrums are picking up right now, but also the particle motion caused by a sound wave, so that you can go beyond saying, oh, I heard a blue whale, to pointing in the direction from which the sound originated. So you get a sense of the spatial distribution of the animals that are calling, that are producing sound. And this is critical because in order to protect endangered species and support their recovery, like endangered blue whales, we have to know where and how they live. And when, of course, because that's how we know how our activities intersect with their lives and how we can tune our activities to be better stewards. So what I want to emphasize here is this 2-month period from 2020 where these black dots represent the percentage of blue whale calls that were coming from bearings that represent Monterey Bay. So this means whales have moved into the bay. And you can see a couple of oscillations. The whales move into the bay, they leave the bay, and they come back into the bay. And the red circles represent the percent of blue whale calling from this bearing range, which is listening habitat for us that is transected by 4 shipping lanes. This is the area where whales can be struck by ships. And so what's underneath these oscillations where they're kind of out of phase? When the whales move into the bay, they're not very much offshore. When they move out of the bay, they're offshore in the shipping lanes, in shipping lane habitat. Well, that's oceanography driving that. John described coastal upwelling, which is represented by these very cold plumes responsible for the invention of the wetsuit and fertilization of the ecosystem. But they also cause the food resources of blue whales to aggregate in very dense patches, and that's perfect for a blue whale. They want to find very dense patches because that's how they can efficiently forage. So when you see these lines, which represent water density rising to the surface, that means a cold, dense plume originating north of the bay is flowing into the bay. There's a cold plume right there. That's driven by the winds. This is upwelling favorable winds out of the northwest. So you get winds driving ocean circulation, bringing whales into the bay. The winds die down, the whales leave and move offshore. The winds pick up again in a series of pulses, upwelling, moves into the bay, and so do the whales. So this is a handle on how they live and under what conditions they're exposed to ship strike risk. And this study in Monterey Bay National Marine Sanctuary is very relevant to what we're considering for the wind energy area off Morro Bay. It's right at the southern end of Monterey Bay National Marine Sanctuary and adjacent to the originally proposed boundaries of the first tribally nominated sanctuary, the Chumash Heritage National Marine Sanctuary. And we've begun baseline monitoring because leases have already been put in place for 3 companies to develop wind energy, floating offshore wind energy. And we began monitoring at a sanctuary ecologically sensitive area immediately inshore of the wind energy area, as well as right near Morro Bay. So we thought this might be important blue whale habitat. We knew this was important sea otter habitat. And one of the key points about listening is because sound travels so well, with blue whales being able to hear each other easily from 100 miles apart, for example, we can better detect their presence with sound. And the limited visual observations did not indicate blue whales were occupying this habitat. However, when we started listening, we were hearing them all the time. The strongest energy indicated in red down here, this is all blue whale calling, blue whale song, in fact, causing the loudest signals in this soundscape. And just to give you a sense of how one location in one day can give you a sense of the biodiversity, we'll listen to a few of these sounds. Up in this high frequency range, we have dolphin whistles, and this mosaic of sound here, number 2. This is a humpback whale singing, and this band of energy starting at dusk, extending till dawn through the night is rockfish. And I would play number 4, but you won't hear it because the frequency is too low and your speakers won't represent it unless you happen to have a subwoofer next to you. actually, that's not bad. That's an A call. So this vertical dashed line shows one other source of data that is critical to our understanding so that we can protect whales, and that is tagging whales, putting instruments on their backs that give us a window into their world from their perspective. And Cascadia Research Collective deployed a tag on a whale off San Francisco Bay. It swam straight down to La Cruz Canyon, inshore of the wind energy area, and foraged intensively day and night, as well as off Morro Bay. So we need to, how passive acoustic monitoring represents the population, we can hear a whole population that is within our hearing range, the individual level from tags is critical to understanding and protection. So I want to highlight the Protecting Blue Whales and Blue Skies program. Its aims and its effectiveness are right on, making great progress in protecting whales and the acoustic habitat of the ocean. Offshore wind energy does motivate understanding animal biodiversity and habitat use in these areas where the technology will be installed and operated. The Morro Bay region is such a rich nexus for so many stakeholders, energy development, technology application, protected habitats and species. And lastly, the prevalence of acoustic behavior in marine species and the powerful transmission of sound through the ocean does make passive acoustic monitoring essential and effective. But we need more detailed observations of the lives of the animals, and tags do that wonderfully. Thank you for listening.
Tia, can we go to the, okay. So we have a really great question, and it's come to us from Jeff Masson. And he says, I'm a commercial fisherman, sea urchin diver. Have there been any studies to determine the effects of seismic noise on the larva marine organisms while in suspension, pre-settlement? So, and so I'm going to refer now to so I want to make a distinction between seismic surveys, which are done primarily for oil exploration, and off the coast of California. We have not had these since the 1980s. I am old enough to have recorded some, but they haven't been here for a long time. We've had a moratorium on seismic surveys related to oil exploration, but there's really good data from the North Sea collected by the Norwegians. And you can imagine Norwegians, they like to produce oil, but they also like to eat fish. And so these surveys were done, basically assessing using what are called hydroacoustics. This is active acoustics. You would see what kind of scatterers are there in this area, both at the sizes that you'd get for zooplankton and also the sizes you get for fish. And then conduct a seismic survey and see what happens. And pretty much it's pretty well documented that the level of things like zooplankton and fish will go down following a seismic survey. Now, nothing like that study has been done off the coast of California, and we haven't had these kind of surveys in a while. But I think you could take that over to say that yes, the sound levels from seismic surveys are so high, 250 dBs or so, that there is some impact to even things like zooplankton and fish. Now, I want to flip the question a little bit to say, there are going to be surveys done in preparation for the offshore wind, but the peculiar kind of wind that we have here in California will be in deep water moorings, where it's not embedded into the seafloor. But I believe what will need to be done to prepare for offshore wind will be shallow water surveys for where infrastructure is being put in, near the coast, for instance, piers or burying cables. And those are a slightly different kind of survey. They would be a mid-frequency, chirp sonar is the typical thing. And I haven't seen the same level of studies showing impact from chirp sonar, but the state of California has a fairly stringent set of requirements. So in order to conduct these kind of surveys, you have to at least have a monitoring for marine mammals to know that you're not in the presence of marine mammals and not being done at night and that kind of thing. So So the answer to Jeff's question is yes, there are good evidence for impacts of seismic surveys, but it's not something that we have here in California, at least at this point. Now, I know that we're short on time, and I'm going to ask Kea, but I think we should get to some of these other questions. So is that okay? So Catherine Baxter, yeah, has asked, can you discuss research related to whale dolphin beaching events and marine sound production in California, relevant or elsewhere? Now, I'm gonna toss this one to Simone, because the beaching events, well, I'll let you take that.
Yeah. As far as I'm aware, there's no clear evidence that there have been direct deaths of whale or dolphins related to marine sound production off our coastlines. I believe there is some anecdotes where there may have been something in the 80s when the Navy first started increasing sonar use, but not as far as I'm aware of any other. I think the noise we are concerned about offshore here is probably more the chronic influence and this population level decline. So the annoyance factor and the behavioral response factor and the not being able to communicate with conspecifics and such.
Okay, new question from Elia Betschen. I'm sorry if I mangled that name. Hi, thank you all for your presentations. I love the graphic from John Ryan following adopting the voluntary vessel speed reduction. How, in your opinion, is this being received by the community? Do you feel that a majority is willing to adopt these measures, or is there still a general resistance? I recall seeing a positive feedback from a similar project in Canada. Now, I want to throw this question to Lindsey. I think this is talking about the speed reduction programs.
Yeah, I couldn't type fast enough in the response. Sorry about that. So it's good we were able to talk about it. Yeah, overall, yes, there's been overwhelming support every year. The program has increased participation from industry, which is a great sign. Even after they've taken away certain incentives and just gone with positive PR, still increasing participation by the industry. In addition to expanding the zone, which Vanessa talked about, they've also increased how they are communicating the results. So they have this reporting, a couple different reporting approaches that offer different bits of details of how each participating shipping line is performing in terms of their promise to slow down. And they've also added an ambassador program, so they can actually work directly with businesses who are using these shipping movements, so they can the general public can understand how is their goods getting from these ships to the shelf, and they can essentially use their dollars to support these conservation actions by the shipping lines themselves and the businesses that are contracting the shipping lines. So there's a lot more nuance there, and I know John Ryan put the Blue Whales Blue Skies website in the Q&A box, so I encourage you to go there and look. They are fabulous at engaging with the media and really getting the positive stories out there. So overall, yes, there's been I think overwhelming success of participation, and that ranges from industry to businesses to the general public.
So here's a related question from Danielle Alvarez, and I'm going to send this one to Vanessa. Slow down policies also mean vessels are longer time in the habitat. Have you come across any assessment of this kind? How about the time vessels are at anchorage waiting to get access to the ports? Shouldn't this be reduced? So, Vanessa?
Okay. Hello. Yeah, that's definitely a really good important point. Do you want a vessel to be going slow, but they're longer, or do you rather just have the vessel speed through and get out of there faster? So in terms of in terms of the noise of the ships, we can compute those metrics in a couple different ways, in terms of ambient noise, in terms of sound exposure level, which takes into account the time that the vessel's in the area, or just a snapshot of the noise right when the ship is at the receiver. And what we've seen from our different metrics and our different analyses of ship noise, we've seen that that reducing ship speed reduces the noise of the vessel, even when taking into account that the vessel's there longer, down to about 10 to 9 knots. And that's why the vessel speed reduction target speed, or one of the reasons why the vessel speed reduction target speed is set at 10 knots. When going slower than that, it starts to increase the sound exposure level if you're going like 6 knots or 5 knots. So that's definitely an important thing to take into account in these vessel speed reduction programs. In your second question, how about the times the vessels are at anchorage, waiting to get access to the ports? This was a huge issue in 2021 when there was that big anchorage congestion off of the port of LA. And because of that, they implemented, the ports on the West Coast implemented a queuing system instead of the hurry up and wait approach, where you have vessels zooming down to the port of LA just to wait for their time to get into the port. They are having a just-in-time approach where the port they'll get their time that they need to arrive to the port so they can slow steam down the coast of California and get there just in time. So yeah, queuing is another operation that's being implemented as a way to reduce noise off of California.
So another question from Arwin Eckboat, and I'm going to send this one to John Ryan. And very simple question here: has ocean noise caused any migration issues for blue and humpbacks? I'm satirical, but what do we know about this, John?
Yeah, I'm not aware of studies that have specifically examined this question, but I think some work led by Megan McKenna is really relevant here. Working with tags on the backs of whales, including blue whales. A study she led found that the blue whale studied at least did not exhibit any evasive maneuvers to an oncoming massive ship. And, instead it just slowly submerged. But the problem there is there's much more ship well below the surface. And so in terms of reducing that risk to the animals, there are indications that they're not trying to avoid that particular threat. But when it comes, there have been other studies though that have shown how cooperative blue whales are in foraging, because their challenge is tremendous. They have to find very dense patches of krill, because that's all they eat, in a massive, vast ocean that's constantly changing. And what a study led by Dave Cade, who was at Stanford Hopkins at the time as a student, what that study showed is that they actually seem to put up acoustic signposts by pumping out a certain type of call we didn't hear in this webinar yet, but at a very high rate. And it brings the animals together to take advantage of that resource while it's there. It's ephemeral. So in that sense, noise would interfere with that fundamental function of sharing information so that they can cooperatively search a vast habitat and successfully forage.
Thanks, John. So we are getting close to the time, but there's a really interesting question from Tekla Maggioni, and I'm going to send this one to Simone. Thanks for the interesting presentations. What emerging research topics, approaches are being prioritized to enhance our understanding of underwater noise and its effect on marine life? How can these insights be effectively integrated into conservation management strategies in the future? Simone?
All right, that's a complex one indeed. So we try to, similar to what John Ryan has shown, we try to have auxiliary information collected together with our ocean acoustic data, where we, for example, know what's the oceanography, what are prey resources right now, what's the variability overall that is underlying this. We try to have multi-sensor approaches where we can, for example, reconstruct dive profiles of animals in 3D over and over months on end. And with that, we can essentially then compare and contrast. This is the location that is impacted versus the location that is not impacted. So for example, if we had equal prey resources, would the behavior be different at this impacted location or not? Would the animals be able to move from and avoid that impact and come to a place where there are ample resources, or are they restricted to being at that productive place that they just have to endure this noise? So those are kind of the type of research avenues that we're trying to follow currently.
Thank you. There is one great physics question in the chat that I'm going to answer, and then maybe we're done. So Aya Verma asked, what makes sound travel faster in water than in air, given that water is denser? Okay, so the thing is, imagine that in any material, there are little springs holding the material together. The springs that hold water together, liquid water, are tighter than the springs that hold air together. So that higher, it's called stiffness, but that higher springiness of water makes the sound travel faster. So there we go. Your moment of physics in. I'm going to send it back to Kia and thank everybody and thank for all the great questions. And,
Great.
hope that you all, keep listening to the ocean.
Thanks, John. Thanks so much. I'll just close this out again by thanking all of you panelists for your time and expertise. We really appreciate it. Super interesting discussion and valuable. I know I learned so much. I wanted to say one more time, thank you to the Scripps Institution of Oceanography at UC San Diego and to the Office of President Pro Tempore Emeritus Tony G. Atkins for their partnership on this event. This event will be recorded and posted to the website. We'll share our contact info in the chat if you have any follow-up questions or want to be connected to some of these great scientists. Now I would invite the panelists. You can turn off your videos and sign off. We'll leave the webinar open for just a few more moments in case you want to copy any links or resources that we shared. Thank you for listening and have a great weekend.